Okay, this is the second vodcast for Unit 6 covering the mole and molar mass. So what is a mole? We can measure mass, we can measure volume, or we can count pieces when we're trying to figure out what something is. Now, we measure mass in grams. In volume, we typically measure in liters or milliliters. But if we're trying to count pieces, we measure in what's called moles. We count pieces that are called moles. Now, the abbreviation for moles is MOL, and the definition of a mole is the number of carbon-12 atoms in exactly 12 grams of the isotope of carbon-12. This right here, this point, you might want to circle it. It's one of those questions that's going to frequently show up on benchmark exams. A mole is defined as 6.02 times 10 to the 23rd representative particles. Now these particles can be atoms, they can be molecules, they can be puppy dogs, rainbows, unicorns, it doesn't matter. 1 mole means 6.02 times 10 to the 23rd things. Just like if I were to say 1 dozen, it doesn't matter what I'm talking about. 1 dozen means 12. A dozen cookies, a dozen students, a dozen eggs. Okay, 1 mole means 6.02 times 10 to the 23rd things. So essentially, this is an extremely large dozen. It's 602 with 21 zeros following it. 6.02 times 10 to the 23rd is sometimes also called Avogadro's number. Okay, so it's named after the scientist Avogadro. And if you check on my classroom on the wall there's a joke from Trader Joe's, Avogadro's number guacamole. So your smallest piece of a substance for a molecular compound is a molecule. Remember, a molecular compound is a nonmetal with another nonmetal. Okay? So our smallest particle for there is a molecule. For an ionic compound, it's a formula unit. This one, remember, formula unit or an ionic compound is a metal with a nonmetal. Right? Oops. And then for an element, it is the atom. Okay, so those are our elements off the periodic table: hydrogen, nitrogen, oxygen, just a single element atom. Okay, the one thing you do want to remember though are your 7 diatomic elements. Those are made up of molecules: H2, N2, O2, F2, Cl2, Br2, and I2. Those always come in pairs. Now, a mole of carbon dioxide contains Avogadro's number of CO2 molecules. So that means 6.02 times 10 to the 23rd CO2 molecules. Each CO2 molecule, though, is made up of how many atoms? Well, you have 1 carbon plus 2 oxygens. So each CO2 molecule is made up of 3 atoms. It's important in this section that you know how to count how many atoms make up a compound. So if we take a look at this example, how many oxygen atoms are in the following? Here's calcium carbonate right there. I have 3 oxygens. Okay. If we look at this next one, Al2SO4 inside parentheses and then 3. This is aluminum sulfate. Now these parentheses right here work just like the math parentheses. So I have the 3 goes on the sulfur. The 3 also multiplies times the oxygen. So I have 3 times 4. That's 12 oxygen. Alright, now the molar mass is the mass of 1 mole of an atomic mass of an element in grams. These are going to come off the periodic table. So if we take a look at sulfur, sulfur on the periodic table has an atomic mass of 32.07 atomic mass units. So that's atomic mass units. That's what the AMU stands for. and therefore its molar mass then is 32.07 grams per mole. So that's saying 1 mole of sulfur has a mass of 32.07 grams. If I were to count out 6.02 times 10 to the 23rd sulfur atoms, okay, has to be sulfur, it would have a mass of 32.07 grams. So if we look at carbon on the periodic table, what's the molar mass of carbon? You find carbon on the periodic table. Now I want you guys to round these to 2 spots after the decimal. So 12.01 grams per mole. If you look up oxygen, okay, oxygen on your periodic table from the classroom, 16.00 grams per mole. You want to be sure you're not forgetting the zeros on the end. These are important, and we're going to use them when we calculate our significant figures. Now, do these things contain the same number of atoms? Okay, does 1 mole of carbon contain the same number of atoms as oxygen? Yes, they do. Okay, 6.02 times 10 to the 23rd atoms. That's how many atoms of carbon make up 1 mole, or how many atoms of oxygen make up 1 mole. But they have a different mass. The carbon had a mass of 12.01. The oxygen has a mass of 16.00. And this is because your carbon has fewer protons, neutrons, and electrons than oxygen. Okay, carbon is element number 6. It has 6 protons. Oxygen's element number 8. It has 8 protons. They also have different neutrons and electrons. So since oxygen has more of those things, it has a greater mass. Now, the molar masses of any 2 elements must contain the same number of atoms. That's what I was talking about on the other slide. Now, if we want to measure the mass of a compound, not just an element, we simply add up the individual molar masses of each atom in the compound. So if we want to know the molar mass of sulfur trioxide here, we have to add up the atomic masses for each of the atoms. So if you look up the mass of sulfur, like we did just a moment ago, 32.07 grams, and we just got oxygen, 16.00 grams. Now, you have 1 sulfur and 3 oxygen. So you need to take 3 of the oxygens. Here's the 1 sulfur, and there's the 3 oxygens right there. And you solve this problem, add them all up, and this is your final answer, 80.07 grams per mole. Okay? In terms of significant figures, again, because this is essentially addition, you're going to have 2 spots after the decimal. Okay, that is what you are looking for on molar mass. Okay, so what we would say here then essentially is sulfur trioxide has a molar mass of 80.07 grams per mole. Okay, so let's try a couple of these here. What's the molar mass of water? Well, I have 2 hydrogens. I look up hydrogen off the periodic table. 2 times 1.01. I have 1 oxygen for 16.00. You add them up, 18.02 grams per mole. Okay, now would be a good time to pause the recording and try these out on your own. Okay, hydrochloric acid, 1 hydrogen, 1 chlorine. Okay, hydrogen's 1.01. I look up chlorine off the periodic table, 35.45. You add those 2 together, 36.45 grams per mole. We're going to use these numbers in the next section to solve some problems. Alright, next we have aluminum oxide. 2 aluminums. So aluminum is 26.98, and you have 3 oxygens, 16.00. Okay, you solve that problem, 26.98 times 2, okay, is 53.96. Add in your 3 oxygens for 48.00. Again, you don't want to forget the numbers after the decimal, and you get 101.96 grams per mole. There's your answer for that one. Now the last one here, magnesium hydroxide. There's 1 magnesium. Magnesium has a mass of 24.31. Okay, now you have parentheses here. This 2 goes on everything inside the parentheses. So you have 2 oxygens at 16.00 and 2 hydrogens at 1.00. Okay, so you add those numbers up, which is what I'm doing now too with my calculator that you should have also. And I get 58.33 grams per mole for that answer. Okay, and each one of these is rounded to the proper number of significant figures.